Hi, today we're looking at increasing and decreasing functions. So let's go ahead and get started. So this is the proper definition of when a function is considered increasing. The definition says that on a given interval, if the graph of a function rises from left to right, then it is said to be increasing on that interval. So in this graph, they're giving us just a very general function. They're giving us this specific interval, which is highlighted here. So on this interval, in between these values, A and B, here between this little section, we see that the values are increasing. They're going up from left to right, and so that means that the function is increasing. Whereas if a function is dropping from left to right, then it's decreasing. So again, we're looking at a specific interval, and so that's what this little graph is demonstrating, that on a specific interval, from left to right, the function values are going down. Now you might see that on this graph, there's actually a larger interval where the function is decreasing, but what the book is trying to emphasize here is that it's always going to be just on a specific interval. And later when we're looking at the examples and we're trying to describe where it's happening, we're describing these intervals from left to right. So that's another little key thing here to remember, is that we're looking at the action of this graph from left to right. And so the last possibility is if your function is staying constant from left to right, the function values are staying the same, then we say that the graph is constant on that interval. So again, grab my highlighter here. In a specific interval from left to right, the function values stay the same, then that means that the graph is constant on that interval. And what we're going to see in the next few examples is that it is possible for a function to have different types of behavior over different intervals. But what's really important is that since we are describing this graph from left to right, that we're using the x-axis to describe those intervals. So let me write that down. We're going to use the x-axis to describe these intervals from left to right. Go. So because left to right is along the x-axis, that's what we're using to describe where these intervals are, where all these behaviors are happening. Left to right, from A to B, from A to B, from A to B, that's where the action is happening. And since we're talking about intervals, we're also going to be using interval notation. And so let's go ahead and look at an example of describing this for some functions. Determine the intervals on which the function is A, increasing, B, decreasing, and C, constant. So I want to start again from left to right, and I'm trying to see, it's kind of like riding a roller coaster. When is the function going up, down, or staying the same? So from left to right, it looks like that my function is increasing on this interval. See that? The function values are going up. And so when I'm going to describe this interval, again, I need to use the x-axis. So I look at where it started increasing. That's at x equals 1. It was increasing all the way up until x equals 4. And so we would say that this function is increasing from left to right from x equals 1 until x equals 4. Now, some people might see this and say, oh, well, this is a closed circle, so shouldn't we use a bracket? Well, the thing is, we're never going to use brackets when we're describing these intervals. And so I'm going to explain why. It's because, again, we're describing like what's happening between those points. And so at the point itself, which would be represented like with a bracket, if we were talking about solutions, brackets, if at that point itself, nothing is actually happening, the function is just staying at that point. What we're describing is when are the function values like increasing? When are they going up? When is the action happening? And the action is happening in between x equals 1 and x equals 4. And so that's why we're always going to be using parentheses when we're describing these intervals. For the next one, let's look and see, okay, when is the function decreasing? So again, from left to right, we're looking at when the function values are going down. And there's actually two different intervals here where the function values are decreasing from left to right. And so if I'm going to write this in interval notation, decreasing. So again, look at this first point where it's starting. This is x equals -1. So it's decreasing from -1 until x equals +1. That's our first interval. And again, it doesn't matter if these points are open or closed. It's still like all the action is happening in between those points. And here's also another reason why we don't use brackets. If we would have used brackets up here at 1 and then at this one, like that, how can you say it's increasing and decreasing at that point? So at the point itself, it's not actually doing anything. The decreasing is happening in between that interval. The next interval where it's decreasing is, let's see, starting here at x equals 4, and then it keeps decreasing all the way down to +infinity. And so let me make this a little nicer. Positive infinity. There we go. And so some students might say, okay, well, wait, the function is going down. So isn't that negative infinity? But you have to remember that we're describing this from left to right. And so if we're saying as these x values get larger towards positive infinity, the graph keeps decreasing. To the left would be negative infinity. So again, when we're describing these intervals where this function is increasing or decreasing, it's always, always, always talking about left to right. And so that's where you have to remember that we're using the x-axis to describe those intervals. And so the last thing it wants to know is when is the function constant? And so we can see here that for this little section, these are where all the function values are staying the same. So to answer this, the function is constant on the interval from negative infinity. So it's going like all the way to the left. So that's negative infinity all the way up until x equals -1. And so those are ways that we describe the behavior of the function within all these different intervals. So let's look at the next example. So again, we want to see when the function is increasing, decreasing, or constant. If you want to pause the video and try it on your own, I encourage you to do that. But let's go ahead and look at it. So again, I like to think of a roller coaster like from left to right. When are you going up the roller coaster? That's when it's increasing. And so we have this interval here. And then we also have this section here where it's increasing. So let me go ahead and describe those intervals using interval notation. So I would say that my function is increasing, let's see, from left to right. We're not saying it's at -10. It just keeps going. And so this left is negative infinity. That was a bad infinity symbol. Let me try it again. Negative infinity. Okay, there you go. So it's increasing from negative infinity up until x equals -8. And then it's increasing again. Let's this x value, -3 at x equals -3 until x equals -2. Something else I want to remind you is we're not looking at the y values. We're not looking at how high or low this is going. We're describing from left to right. When is this behavior happening? When are the function values increasing from left to right? And so that's when our graph is increasing. So now let's see, when is the graph decreasing? Looks like I have one interval here. And so if I'm going to go ahead and write that, we say that the function is decreasing. Let's see, it starts at x equals -8. And it keeps decreasing until x equals -6 from left to right. And finally, when is our function constant? And so it looks like we have two intervals for when the function is constant. And so again, from left to right, I'm going to say, let's see, these values are the same from -6 until x equals -3. And then it's constant again from x equals -2. And then for the rest of the x values, so positive infinity. So left to right, looking at the x values. When it's time for us to look at the y values, that's when we start talking about maximum and minimum values. So on our next slide, we're looking at the relative maximum and minimum values of a graph. And so with this lesson, I like to emphasize the word relative here. So relative is not the same as like the absolute. It's not the absolute highest point or the absolute lowest point. It's relative to the points around it. And so this is saying, suppose f is a function for which f of c exists for some c in the domain. So we have all these different like output values that exist. We have a relative maximum if there is, again, an open interval such that that y value, f of c, is greater than all of the other y values in that interval. I like to think of it as just like a high point. So we're looking for a high point on the graph. And so if we look over at this example, we see that here we have a relative maximum because in relation to the points that are immediately to the left and right of it, it is the highest point in that little interval. We're not even specifying the interval. We're just saying that compared to the points in its immediate vicinity, it is the highest point. So that's the relative maximum. It's not the absolute highest point because we do have like higher points over here on this side of the graph. But again, that's not what we're looking for. We're looking for points that are higher relative to those in its vicinity. And so if we're looking for a relative minimum, then that's going to be like a low point. And so if I look at this example here, so again, for relative minimum, it's just lower than the points in its immediate vicinity. So on this graph, we actually have two relative minimums. So here, this graph is lower than the points immediately to the left or right. Same thing here, it's lower in relation to the points immediately to the left or right. So there are actually two relative minimum here. One of them is an absolute minimum, but again, that's not what we're worried about. We're just looking at relative to the other points around it. What is that value? And this is when we're going to use the y values to describe these. And so for just looking at when a graph was increasing, decreasing, we were looking at the x-axis to describe that interval. Now, when we're identifying the maximum and minimum, we're going to use that y-coordinate. So let's look at some examples. To graph the function and identify the intervals on which the function is increasing or decreasing and any relative maximum or minimum. So to help me do that, I'm going to bring over my graphing calculator and we'll just look at how we can graph this on a TI-84 graphing calculator. And so I'm going to start by going to y equals and typing in the equation of the function. For absolute value, I go to the math menu and then I go over to where it says number and it's that first option there. So let me just do that again. I go to y equals, I go to math. Let me see if I can highlight this. Here we go. And then I'm going to the math button and then over to the number menu and then press enter to enter the absolute value bars. And then I'm doing x plus 3. So next to alpha is the x plus 3. Let me move my cursor over and then minus 5. And so when I press graph, I'm looking at this absolute value function. It's been shifted left 3, down 5. And I want to determine when it's increasing, decreasing, and any relative maxima or minima. And so first, looking from left to right, it looks like this graph is decreasing to begin with. And then it turns and starts increasing. And so first, I'm going to describe when is it increasing. And again, we're looking for this x value. Sorry, my lines are a little off here, but I would say that it is x equals -3, where our turning point is. And also that's why it says estimate. So we're just kind of eyeballing it here. If you want to go through the calculator and like verify where that vertex is, it's fine. But I'm going to go ahead and say -3 is that point where the vertex is. So our graph is increasing from x equals -3 to positive infinity. So all the way for the rest of the x values. It is decreasing from -infinity to x equals -3. So again, to the left, it's decreasing for the entire function values up until x equals -3. And now for any relative maxima or minima, this is the plural of maximum or minimum. We just want to see, is there any high point or low point? And I think hopefully it's kind of a little obvious here that we have a low point right there. And so that would be our relative minimum. And so this is a relative minimum. And this is where we use the y value. And so that y value, 1, 2, 3, 4, 5, is at y equals -5. So for increasing, decreasing from left to right, that's where we use the x-axis to describe. To find the relative max or min, we're using the y value. The relative minimum is y equals -5. And you might be asked to determine where it occurs. And this occurs at x equals -3. I'm just going to roll with it that my handwriting is bad today. So let me know if you have any questions. But let's go ahead and look at one more example. And so we want to graph this function and determine where the relative maximum or minima are located. So let me go ahead and bring back my graphing calculator. And I'm going to go back to y equals, and I'm going to clear this equation. And now we're doing -x squared minus 8x minus 9. So I'm going to do -x raised to the second power minus 8x minus 9. And when I press graph, you may have already been thinking that this was going to be a parabola because of the x squared function. And it looks like we have a parabola opening down. And so again, I'm going to start by looking at when is it increasing, when is it decreasing. And so it looks like we have a turning point right around here. 1, 2, 3, 4 at x equals 4. It's increasing first, and then it's decreasing. So we say that our function is increasing from -infinity until x equals -4. And then it is decreasing. Yep, decreasing after that. So from x equals -4 to positive infinity. Again, the fact that like the parabola is going down doesn't have anything to do with what's happening from left to right. So from left to right, it's from -infinity to x equals -4, increasing, and then it turns and starts decreasing for all the rest of the x values to positive infinity. And then it looks like we have a relative maximum. There is a high point that is higher than all the others. We're going to find that y value. Let me just give you a little thing that we can do here. I can go to the calculate menu and to see like what that actual vertex is. So I'm going to go to, I don't know if you see calculate here is next to the trace button. So I'm going to hit second trace. And let's see. Oh, it says I can calculate that maximum. So I'm going to press enter. And it's going to ask for a left and right bound. So I'm just going to tell the interval that I'm looking for that maximum value. So I'm going to go to the left here. That's good. Just press enter. Go to the right. So again, I'm looking, since it is a relative maximum, I'm giving the calculator this interval over which I'm trying to find that point. It says guess, I press enter, and now I see, okay, yeah, so -4 was good for our x value, the y value is 7. So now I can come back over here and say for certainty that my relative maximum is at y equals 7, and it occurs at x equals -4. So that's it for increasing and decreasing. You can, if you're in my class, you can message me if you have any questions, or you can comment on the video below. Thanks so much for watching.